Any questions at all before we get going? All right, so last time we talked about factoring trinomials of leading coefficient 1. We're going to extend that idea today, but I want to go through a few more practice before we do that. Make sure that we're all on the same page with getting these types of polynomials factored before we go on to where we're going to change that leading coefficient to something other than 1. Just to remind again, what do we mean by leading coefficient? Hello. What does it mean for the leading coefficient? Which coefficient are we looking at? Okay, let's start here. What are, for this first one, what are the coefficients? The 7's one of them, yeah. The 12's another one, and a 1, right? Coefficients are what you multiply in the front here, right? Well, there's not necessarily a variable right there, but we still call those the coefficients. So 1, 7, and 12 are your coefficients in this particular case. What does it mean to be the leading coefficient? Which one are we looking at? Yeah, the one that's on the highest power, right? So the leading coefficient here is a 1. That's a 1x squared. That's what we mean by a leading coefficient of 1. We're going to change that leading coefficient to something other than 1 here today when we're doing some factoring. But again, I want to practice a few more, make sure we're all on the same page with this before moving on to the next one. Okay. So let's look at this first one here. I want to factor that x squared plus 7x plus 12. What do we do first? Find the factors of 12, right? So if I look at that 12, what do we have for pairs of factors? 1 and 12, and 2 and 6, 3 and 4. So again, start with your 1, pairs with 12. 2 definitely goes in, you're left with 6. 3 definitely goes in, you're left with 4, and you've already found the 4, so you're done. You know you're done with pairs. Okay, so that's always your first step, looking for the factors of that number. What do we want to do next? Yeah, see how to make 7 out of that, right? So which 2 do you need to make 7 out of it? The 3 and the 4? Okay. So then how is this going to, we're going to use the 3 and 4 because when we add those together we get 7. So how does that factor then? Good, x plus 4 and x plus 3. Is that okay? Seem familiar for what we did last time? Okay. All right. Let's skip over B because B is very similar. Let's do C. Same process again. We want factors of which one? The 14. Good. What are your factors of 14? I think that's it, isn't it? Because 3 doesn't, and again, if you need your calculator, that's fine. 3 doesn't go into 14. 4 doesn't go into 14. 5 doesn't go into 14. 6 doesn't go into 14, and you already found the 7. So you know you're done. Say it again. Right, you have to worry about the negative. That's exactly right. So remember again here, this plus sign means what? They both are the same sign, and since it's negative here, they both are negative. That's exactly right. So which of these two things are we going to want to use? 7. The 7 and 2, because we'll do negative 2 plus negative 7 gives you negative 9, right? So I want negative 2 and negative 7, right? Because again, this means they're both the same sign. This means they both have to be negative. So how is this going to factor now? Good. So far, so good? Okay. Let's look at E. because it's a little bit different. Again, first thing we want to do is what? Factors of 30. So certainly 1 and 30. What else we have? 2 and 15, good. Yeah, 3 and 10. 4 doesn't work, right? 4 doesn't go into 30, but I also heard 5 and 6. And again, now we know we're done because we got to 6, right? We went to 5 and then 6 was on the other side, so we know we're done. What's that thing tell you? Yeah, 1's positive and 1 is negative, right? So we should start checking which ones work. Well, we need to end up with a positive 1, right? Which one do we need to use to get a positive 1 by making 1 positive and 1 negative? Yes, positive 6 and negative 5, right? So now what does the factor look like? Good. So again, remember we had to do the combinations of these, whichever one works, to give us that coefficient when we add them together. Questions on that one? Before we go on the new stuff, let's do one more type here. Let's look at H to start with. If I look at H, what's the leading coefficient? 2. We already said the leading coefficient needs to be 1 to do what we're doing, right? So this is what I mentioned the other day. What's the first thing that you should always check for before you do anything else? A GCF, right? Do you see a GCF in this one? Yeah, what's the greatest common factor for this one? 2. So let's pull that out first. What are you left with? Good. All right. So pull out the 2, leaves a 1 on the x squared, leaves a 4 on the x, and leaves a 12 for your constant. Now what do we do? Good. Now we want to factor this piece. So we're going to find the factors of 12. What are the factors of 12 that we can pair up here? 1 and 12. 2 and 6, good. 3 and 4. And again, since we found 4 on this other pair, we're done. We know that's it, right? What does this minus sign tell us again? One's positive and one's negative, right? So we need to match up 1 positive and 1 negative out of these things and see how we get what number? What number are we trying to get? -4. All right. So what do we need to match up to get a -4 here? Good. We need 2 and 6 because I need a +2 and a -6 to give us -4. Right? So what are your factors? Good. Good. Yeah. 2, x plus 2 and x minus 6. That okay? Let's do one more where we have to factor off a GCF. Let's look at, I want to scroll down here. What do I want to do? Let's do letter M there. Work on letter M for a second. That 4x squared plus 24x plus 20. Work on that one for a minute and then we'll chat about it. while you're working on that, I'll pass out the new stuff here. Maybe. There should be two there. Oh. You're welcome. So sorry. I didn't mean to throw that at you. I was just trying to slide it. Oh, I'm sorry. That's all right. It made more sense when I had an uneven number left over here. My apologies. It's really hard to count. Ready to talk about it? Yeah? All right. Looking at letter M here, what's first step? Yeah, find that GCF. What is the GCF? 4. Pull out the GCF, you're left with? Good. Everybody okay with getting the GCF out? Yeah? Okay. Again, I know I'm harping on it, but make sure you always look for that GCF first. Okay? Makes your life easier if there is one to get that out of there. All right, what's the next step? Good. Find those factors of 5. What are the factors of 5? Yeah, 5 and 1, right? That's it. It makes it pretty straightforward. The plus sign tells you what here? They're the same sign, right? It says it's positive, they'll both be positive, right? They better both be positive. So does positive 1 and positive 5 give you positive 6? Yep. So what's it going to factor as then? Good. 4 times x plus 1 times x plus 5. Any questions on that one? All right. I'm going to leave the rest of these for practice for you. The answers are already on Moodle for all of these, so you can check your answers on those. But let's go on to the new stuff. The new stuff has to do with factoring trinomials, same stuff we've been doing, factoring trinomials, but when we have a leading coefficient other than 1, what are we going to do? So that's the whole point of this one is factoring when we have a leading coefficient other than 1. So let's run through this specific example using what we refer to as the AC method. The reason why we call it the AC method is because ordinarily when we write a trinomial, we write the x squared first, we write the x second, we write the constant third, and then we label the coefficients with letters and we use alphabetical order. So A, B, C. So the AC method involves the number that's multiplied by the x squared, that leading coefficient, and the constant on the end. Okay? So the first step in doing your AC method is take the leading coefficient and the constant term and multiply them together. So that's step 1. Okay? So we do 2 times 12 gives us 24. The next step is exactly like what we did in factoring our trinomials of the leading coefficient of 1. I first find the factors of 24. Do that first. Okay? Factors of 24 are what? We can do 1 and 24, 2 and 12, 3 and 8, good. 4 and 6, and then that's it, right? Because 5 doesn't divide it, and we already found 6. Okay. So that's the same, that's exactly the same thing we did for the previous ones, right? Found those factors. The next step is also exactly the same. Okay. This number here tells you that both of them are going to be the same. This tells you that both have to be positive, right? So looking at these factors, how can you get plus 11? 3 and 8, positive 3 and positive 8, right? So we're going to use plus 3 and plus 8, okay? Here's where the little bit of weirdness comes in, but it's not too bad. So going back up here, here's the polynomial we're trying to factor. We're going to rewrite that 11 as 3x and 8x. We're going to split the 11 as 3 and 8. Why did I use 3 and 8? What we found in the previous step. Okay? That's why we use 3 and 8. There's lots of different ways we could write 11. We chose this one specifically because of what we found here. Okay. How many terms do I have now? 1, 2, 3, 4. I said we had exactly one way to factor things when we have 4 terms. That was factor by grouping. That's exactly what we're going to do now. Remember factor by grouping? We treat the first 2 as a group and the second 2 as a group. What's the GCF of your first 2? The 1 for the coefficients, but 1x, right? So I can pull out an x. When we pull out x, what are you left with? 2x plus 3. What are we looking for then in the second term? 2x plus 3, right? We want to see the same thing. What's the GCF for the second one? 4, and you're left with 2x plus 3. Good. What do we pull out now? The 2x plus 3. When we pull out the 2x plus 3, we're left with x plus 4. And now we've factored it. You've all got the hang of it now, right? We don't need to talk about it anymore? We're doing 7 more examples. I'm just being silly. All right. So this is AC method. All right. We use AC method when we've got a coefficient other than 1 as our leading coefficient. And this is the steps every single time when you do that. Okay. So let's see if we can do some more of these. Make sure that we're all on the same page. Let's just go through these first few here, and then I'm going to let you go crazy on the worksheet that I gave you. All right. So again, the first thing that, again, you should always look for is what? That's all. Step 1 is always what? GCF, right? Do I have a GCF here other than 1? No, because nothing goes into that 23 nicely, right? Okay. So AC method says to do what first? Multiply the 3 and the 14 together, right? That's step 1. 3 and 14 give you 42. So the next step is to find factors of 42. Good. What works for that? Okay, so here's what we're going to end up with here is right. But in general, we would have 1 and 42, 2 and 21, 3 and 14, 4 doesn't work, 5 doesn't work, but 6 and 7 work for factors. Again, if you need your calculator, use your calculator, right? Divide it by 2, see if it goes in. Divide it by 3, see if it goes in. Eventually, you'll get to a pair, and then you'll start trying to count up the other way, and you'll be done. Okay. All right. The plus on the 14 means what for us? Same, yeah, they're both the same sign, and the plus here tells us that they are both positive. Okay. So I need the sum of these things to be what? What do we want these add up to? 23, right? I want the number in the middle. What gives you 23? The 2 and the 21, right? So our next step then is to write 3x squared plus 2x plus 21x plus 14. We rewrite the 23 as 2 plus 21. Now what do? Group, right? Group the first two, group the second two. What do we multiply out of the first two? An x. When you factor out an x, you're left with 3x plus 2. So what are we looking for in the second piece? 3x plus 2, right? If this is going to factor, we have to see the same group. GCF in the second piece, 7, left with plus the 2, right? Which is exactly what we wanted to see. So now you pull out the 3x plus 2, what are you left with? X plus 7. Good. That one okay? Let's do one where the signs are different, right? The ones, the examples we've done, they've been the same sign, they've both been positive, right? So let's look at the next one. Again, first thing that you would do is what? Look for greatest common factor. It's always step 1, right? Is there a GCF of those? No. That's good. We should always check. Notice I keep saying that because look at your next one. Is there a GCF there? I think 3 goes into all of them, right? So you'd have to pull out a GCF on that one first. All right. What's your next step in that second one? What do we do? Yeah, multiply, right? 6 times negative 5 gives us negative 30, right? Okay. Again, now that we have that negative sign, that tells us what about the numbers that we're looking for, by the way, since it's negative? One's positive and one's negative, right? Okay. Now we need factors of 30. 1 and 30. What else? 2 and 15. 3 and 10. 5 and 6. Good. And that's it, because now we're at 5 to 6. We're done, right? You know we got all the factors. You just told me one has to be positive and one has to be negative, right? And what does it need to add up to when we're done? Negative 13, right? So what are we going to have to use to get negative 13 looking at these pairs? So if I do the 3 and 10, they would both have to be negative, right? So I need to use what? Yeah, positive 2 and negative 15, right? You were right. If I use 3 and 10, I can make negative 13, but they both have to be negative, and we need one to be positive. So that was why that one didn't work. So we're going to use a positive 2 and a negative 15, right? So we're going to write 6x squared, and then what are we going to write in the middle? Plus 2x minus 15x, good, minus 5. What's next? We're going to group them, good. Looking at the first two, what can you factor out? 2x, fantastic, good. There's a 2 in both coefficients and there's an x in both terms. You pull out the 2x, you're left with 3x plus 2. So I need to see a 3x plus 2 in the second chunk, don't I? What do you need to pull out? Yeah. I would have an x, sorry. You wouldn't have a 2, you're right, it's a 1. My bad, sorry. You're exactly right, thank you. 3 should be 3x plus 1, sorry. We pulled out the whole 2x, it should be left with a plus 1. Sorry about that, you're exactly right, thank you. I need to see a 3x plus 1 in the second term. What do I need to pull out of the second piece to see a 3x plus 1? Got to do 5, and I need to pull out the negative, right? Because there's a negative in both of them. What are we left when we pull out negative 5? The first term has a 3x. Notice we pulled out the negative, so we're left with plus 1. So what's the final step then? So we pull out the 3x plus 1, and we're left with the 2x minus 5. Good. Questions on that one? It's the same process every time that you want to do. Okay. So go ahead and start working on that worksheet. Be around to answer questions as well.